Welcome to this video where we will be simulating a deck of cards. The first thing I would like to say is that this video is going to be a little bit longer than the usual. I'm not sure how long it's going to take, but it's going to be longer than the usual, almost double, if not more than that. Okay, but the main objective of this video is to show you a deck of cards simulation. And then when we create the simulation, we will create a class of cards like you can see here. And then we'll create a class which has deck of cards, and then we will test it here in this file. So we've got the three files that you'll be working with. The first file will have, or the first class will have a card object, just a card like normal cards that are usually used for gambling sometimes. And then the deck of cards is one that is going to contain multiple card objects in an array. And then when we go to the other file, the deck of cards tester, that's where we'll be testing our deck of cards. So our objectives for this video is that when you finish watching this video, you should be able to generate bounded random numbers using the random class in Java, something you're still going to see. So the random class, what it allows you to do is to generate random numbers. And when we say they're bounded here, so we'll be specifying the bounds, like how small can the smallest number be, and how big can the biggest number, be in the random numbers that we're generating. So we can set the bounds like between 0 and 10. So we know we're generating random numbers between 0 and 10. Sorry. And then the other one is to be able to populate an array with objects. Previously, we were using primitive data types like integers and on doubles. So in this case, we will be populating an array using objects. And then here I'll also show you how to swap values of two variables, and then at the end I'll show you how to shuffle or elements or objects of an array. And then okay, we can just begin with the card. So the card class will have let me just remove this first. Thanks. And then I'll reduce the font size a little bit to the normal one. Yes. So our card class will have some attributes first. So a card is called, it's an uppercase, private. So we need the face of the card. Like, okay, we'll show the values here. And then we also need, for the card, we also need the suit, private string suit. Yes, so the possible faces are ace, 3, 4, 5, 6, jack, the queen, the king, is normal in cards. So that those are the possible faces. You can either have an ace, a 3, 2, 4, 5, all those. And then the suits are the hearts, or is it a diamond, or is it a club, or spades. So basically, we're having these two attributes for the card object. And then here in the card object, we want to be able to create a card using a card face and a card suit. So we should define a constructor for that one. So public card, and then here we specify string card face, and then we've got a string, card suit, like that. And then when we supply these two parameters here to this constructor, we want to initialize these values. So here I can say face equals to, and then I can say suit equals to, and then I'll just copy these values and paste them at the bottom. Like you remember, a constructor's main duty or main function is to initialize the variables of the current class. Yes, so we have a constructor now. We have these two attributes and then the constructor. And then we want to define a toString method for this class. So that one is going to be like this: public string toString. And then what we simply do is just we return face plus of plus suit, like that. Oh, sorry, I put an E here. Sorry, I made a mistake. Yes, now it's fine. Thank you. So that is all we need for the class. So we've got just two attributes and the constructor, and then the toString method. Okay, so this one will represent a single card object. We identify a card with a face and a suit. So the face is the one containing the numbers or the queen, the jack, and all those, like I explained earlier. And then the suit is either a heart or a diamond or spade and all those. So here we have we've got a constructor, sorry, that receives a card face as a string and the card suit as a string and assigns those to these two. So we'll use it to create card objects, and then this one we're going to use it to print out the values of the card objects. Okay, so now we are moving on to the next class, which is a deck of cards. So now in this deck of cards, we will be having an array that will contain card objects. Okay, and to define that array containing card objects, we simply do private, and then we say card, like that, and then we will name it deck, just deck, like deck of cards. And then what we also need is an integer, is this variable private int current card. So this variable, the first one is a deck. It's an array of type containing objects of type card, and then the second variable, current card, is a variable of type integer, and it's going to be an index actually in the array of cards. So we're going to use this variable to index elements of the deck array, which contains objects of type card. And then here we also need the length of the array, sorry. So we hit static and then final, because we know it's definite, it's a constant, it doesn't change. And then here I'll just say number of cards. Let me see what went wrong here. So here I've got private, static, final, number of cards. Let me just see the error message. So float expected. Oh, okay, I didn't specify the data type. Public static final, and then here I can say int, like that. Okay, yes, that was a problem. So this video was created in South Africa. Actually a South African. I'm just specifying this because we might be playing cards in a different way in different countries. So in South Africa, when you're playing cards, we need 52 of them. So that is why my constant, I'm defining it and I'm giving it the value of 52, is because normally in our casinos or where people mostly play cards, we usually use 52 cards. Okay, so now from here, I also need to define a variable that will contain, or that will be of type random, that we will use to generate random numbers. So for that one, I have, let's just say private static final of type random, and then here I'll say random numbers, sorry, equals to, because it's an object, it's equal to new random. And then here it's underlining I should import the package where I can find this. Import java.util like that. Okay, so what we just did here, we're just specifying the attributes for this class. So this class contains an array named deck of type that will contain objects of type card. The current card variable, which is of type integer, that will be used to index elements of the array. And then here, the length of the array as a constant. And then here we also have a variable or an object for generating random numbers. So this class, this random keyword, or not really, it's not a keyword, but it's a class name. It contains or it defines objects that can produce, random numbers, and these random numbers are produced based on some specific bounds if specified, like we're still going to do later. But you can play around with this right now, or just Google it and find out more about it. But more specifically for this video, you'll see its usage later, and I'm still going to explain what it will be doing when we're using it. So just don't worry about it for now, but just remember it and know that it will be used to generate random numbers. So now for this class, we're done with defining the attributes. Now we move on to the constructor. So we have our constructor here, public deck of cards. Let me just copy the name as it is. So I'm just going to copy this name here and bring it down here, and then we have path. Okay, so here in our constructor, we want to define or want to initialize all these variables. Or actually, we initialize this one and this one. We need to initialize these two and use them. Okay, so what we'll be doing here is that we need to define some arrays for the faces, the possible faces of a deck of cards, for cards, and the possible suits, so that we can use these two arrays to initialize objects of type card, and then store them in the deck of cards. So we just need to define here the faces and all the possible faces for cards. And then here I've got an ace, and this one is a deuce. Yes, I want to make sure I'm spelling it right. And then we've got a 3, and then we've got a 4, 5, 6, 6, and then 7, and then 8, and then you can just come here, 9, and then after 9 we do not have okay, we have the jack, and then the queen, and then the queen, and then we have the king. Yes, so I think here I missed a 10, sorry. After the 10, it's a jack, a queen, and the king. Okay, these are all the possible faces for cards. We're going to use them later here. And then we define all the possible suits. The possible suits, it's just 4 of them. First one being the hearts, sorry. And then the other one being diamonds, and then the other one being clubs, and the other one being the spades. Sorry about that. Yes, we've got the spades like that. Okay. So now we have defined the possible faces and the possible suits. And then now we can initialize this deck as a new array that will contain objects of type card. How many objects of type cards? This is the number now. Now we are using this number here. Because it's a constant, we just use it like that. You could have put the 52 here. It's still acceptable, but not a good practice normally. And I'm always encouraging this. Please use the normal standards for programming. So now here, now that we have created or initialized this variable deck, we should now populate it. We need to populate this. So populate the deck. So to populate the deck, we'll just do something very simple. So for int I, let me just use count equals to 0, count less than the length of the deck. Sorry, it's producing the hash code. So count plus plus. So now this one, this for loop, what it will do, it will go for every index in this array of type cards, which is named deck. So what we want here is that at the index in the deck array, in the deck array, at the index of count, we want to put an object of type card. So we want a new card, okay? We want a new card at the index count in the deck array. And this new card will have a, like we said first, it should have a suit, a face and a suit. So for the face, we want to take a face from this array, and we also want to take a suit from this array. So the way to do it here is to just say faces. What is the index? It's an index count. But what if count exceeds the length of this one? So we want it to start afresh, like 0, 1, 2, 3, 4, up to 13. And then when it goes to 14, we want it to come back, like keep iterating like this one. Because for every an ace will have a heart, a diamond, a club, and spades. An ace alone. A deuce will have a heart, a diamond, club, and spades. A 3 will have a 3 of hearts, a 3 of diamonds, a 3 of clubs, a 3 of spades. So here what we'll do, just put count mod 13. Okay, for the faces. And then for the suits, you put count divided by the 13. Sorry. Oh, yes. Yes, that is it. That is it there. That is it. So here you'll see what will happen. So like in this case, we'll have, let me just show you a little bit how this is going to work. So a deck, we're saying here, deck at index count, we want a new card. Here we're putting the face, count modulus 13 for the 0, between 0, 1, 2, 3, 4, all the way up to 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. These will be producing the exact indices, like between 0 and 12. And then after 12, when it goes to 13, 13 modulus 13 is 0. So it comes back here. And 14 modulus 13 is 1, so it goes here. 15 modulus 13 is 2, so it goes here. So it will keep iterating the faces until for all the numbers all the way up to the maximum. And then for here, sorry, so for here, so 1 divided by 13 will give you 0. This is Java, remember, and we're doing integer division here. 1 divided by 13, so and then 2 and all those. And then when the count keeps increasing, it will also be, we'll just be getting things right. I would just say that. You can print this out and see what it's giving you, just for more clarity, but it's going to work. And then here we need to come to, okay, we're done with the constructor now because we initialized the deck, and we still, okay, we haven't used this one, but we're still going to use it. So this is where our constructor ends. Yes, this is where our constructor ends. Now we need to define a method for shuffling the cards. Now we need to define a method for shuffling the cards. So the way to do it is public void. It's not going to return anything. Shuffle. Yes, it's very important. It's very important that you leave lines here to make it presentable. So now here what we'll be doing is just say, okay, current card. Now we're using this variable now. Let me just go and copy it here so that you see that we're using this variable. Okay, this is it. Now we're here, we're saying, okay, our current card is equals to 0. Okay, and then now that we already know when we're shuffling the deck of cards, it means that the deck of cards already exists. So now we will be iterating the deck of cards. Sorry. And then here I say int first equals to 0, and then while the first is less than deck dot length, and then here I say first plus plus. So this first variable is for the first card, but then it's going to make more sense if I define a second one. Second equals to. Now we want to be swapping like for this iteration. First, let me just cancel this and explain what we'll be doing here before we start doing it. So what we want to do here is we want to visit every index in the deck of cards. We want to visit every index, and each time at each index, we want to pick another card randomly and swap the current card with the other randomly chosen card within the same deck. So at the end, we will end up with a shuffled array of cards. So can I just repeat this? What I want to do here is that we want to iterate or traverse the array of cards, which is named deck, which is a deck of cards basically. So what we want to do is that at every index, we want to swap, we want to pick another random integer, which is an index bounded between the 0 and the length of our array, and we want to swap whatever card we find at that randomly chosen index with the current card, like the card at our current index, and that card is going to be referred to as index first, as an element at index first. So now here, when we define the second element or the second card, it should be a card that is at an index that is chosen randomly, because when we're shuffling cards, we want to make sure that they do not possess any order. Okay, so here we're using our object random number, the one we defined earlier, dot next int. And then here we sorry, see? So here we want to bound our random integers between 0 and the length of our array, and the length of our array, sorry, is defined by this constant. So now we bring this one back here. Yes, let me just see if I spelled this one correctly. Yes, it's random numbers. I'm wrong here. Yes, now the spelling is right now. So now our first card is at every index from 0 to the length of the array. The second one is chosen randomly, but it is also bounded between 0 and the length of the array, but it is chosen randomly. So the random object has this next int method that has now been supplied with this parameter, number of cards, and the value of this parameter is 52. So this one will have a number which is 52. So our random numbers will be between 0 and 52, excluding 52. Okay, so now what we do each time is that we'll define a card, and this one is called, we call it temp, which is equals to deck first. So our temp variable, which means just temporary, short for temporary, we are picking the element at index first. Index first is not always going to be 0. It's going to start from 0 up to 51. So our temp variable is given the value first. Okay. What we want to do now is that we want to swap the element at index first with the element at index second. So to do that, we define a temp variable to hold a value of the element at index first in the deck array. Now that we have an element, or we have a variable, sorry, holding a value of the element at index first, we can now define what should be at index first. V. So what we want at index first is actually the element at index second. Okay, so now you see what we've done here. We've created a temp variable. This temp variable holds a value of the element at index first. Okay, so we now define what should be at index first. At index first, we put the element that is at index second in the deck array. Now the element at the second index in the deck array has been duplicated. It's appearing twice in the array. So we want to replace the element at index second as well with the element that was initially at index first, which is now temp. Because now at index first, we have the same value as the one at index second, like you can see in this line. The element at index first is the same as the one at element at index second, but we want now to change the element at index second to be the element which was at index first initially. And to do that, it's very simple. We just say deck at index second put temp. This is a very important concept in computer programming. Being able to swap two variables, it's very simple, yes, but you need to make sure that you understand how this works. Don't just memorize the position, because there is a pattern you can say. Deck first, so here you've got deck first, deck second, temp, temp. So the variables are appearing diagonally, but you shouldn't memorize this. You should try to understand it. I'd advise you to draw some boxes as containers for all the indexes and see what really, how the exchange is happening. But this is how it's done. Okay, now with this shuffling, because the index first will go from 0 to 51, so we'll shuffle every card that we find. Okay. Now we will be, sorry, let me just remove this. I think we don't need this yet. I think we don't need this one yet. Just cut it there. I'll see when we need it. Okay. Yes, this is the end of our shuffle method. And then now here we will be defining a method called deal card. Public now card, and then here deal card. This method is very simple. What it does is just it returns the next available card in the array. So what we're checking here is if the current card, which is an index, is still less than the deck.length. Okay. And if that is so, we just return deck, the element deck, which index current card plus plus. So the index current card should start from 0, and I'm still going to define that at the top. So we do this if the current card index is less than the deck of the array, else we just return null. Yes, return null. So this method returns a card, and it's named deal card. It returns a card if there are still any available cards in the array. That is very simple. That is how simply it works. So now here, I think I should have made this one static as well. Yes, and then, so the reason I'm making it static is so that it's every card object is aware of this current card index. Then there's something else I need to do here. I need to initialize this value. I think it should be fine if I initialize it here. Yes, to 0. So that when I initialize it to 0 here, is so that when we do this plus plus, we're actually incrementing on something that already is initialized. So that is the point of it. I think now we are done with the deck of cards class. So in the deck of cards class, we have the attributes, we have the constructor, we have the shuffle method, we have the deal card method. Now, when testing our deck of cards, let me just go back here and copy the class name. So what we will do here, okay, now we are testing this. So just say V. So a type of deck of cards. And then here put deck of cards is our variable name is equals to new V. Yes. So now let's just print out every element in this object. The reason we're printing them out already is because when we do this, they are created, but not before I run this. So we can just do for int I equals to 0, and then while the I is less than our 52, and then we do ni plus plus, and then system .out.println, and then we print a deck of cards dot deal card. Yes. So this one, when we print deck of cards dot deal card, it will automatically invoke the toString method for the card object. It will automatically invoke this method. This method is predefined for most classes in Java. And each time we're doing this, we're actually overriding the method. I would advise you to Google what overriding in Java means, since that one is an entirely different concept and it's outside the scope of this video. Just go and find out on Google, please. So I can run this and see if we get anything for now. Yes. So there we have some output there, but this output is not very pleasing. It's not very nice. So we can maybe modify it further and say, okay, put some commas here. It's still looking bad. Okay, now what we can do is maybe we can print, how many can we fit? Maybe 6 cards in a row. And then here we'll say if I mod 6. Now maybe say use 5 equal to 0. So if our I modulus 5 is 0, we just go to a new line. And it's best to do this after printing this, because for I equals to 0, we'll skip a new line. We'll go to a new line for no reason. So it's better to do this after doing this. I believe you understand this one. So what we're doing here is that we're saying, okay, if our I variable modulus 5 is 0, then go to a new line. So from 0 to 4, we'll be printing on the same line, and then at 10 we'll go to a new line again, and then when it's 15 and 20, all the multiples of 5 will be breaking each time. So I'm going to run this. Okay, yes. So now this, maybe we want to print it in the same line. Yes, not just run that. It's very ugly. We change this a little bit. Yes, now it's ugly, but it's something we can look at. So these are our cards. This is our simulation of the cards. And if we were using graphics, now this could be like, you'll be able to see cards being dished out. But these cards have been produced using the program we have just worked on. If you see some irregularities with this, the way I've done it, it's okay. Actually, this program it appears in most of the Java programming books, and I was also inspired when I looked at one of the books, in Java. It's titled Java How to Program, ninth edition. I've forgotten the author though, but yes, I was inspired by that book, and I think this is very useful because now you learned how to populate an array with objects. You learned how to use the modulus and the division very effectively. You learned how to shuffle elements, which is very important. You learned also that the toString method can be invoked without actually calling it, like what happened here. You also learned here a very interesting thing, returning an element conditionally. If the current card is this, satisfies this condition, return the card, otherwise you return null. So returning conditionally. You learned how to shuffle elements. So this is how you swap an element basically with another one. And then if you do it iteratively for every element in an array, then you're swapping the elements. And then here you learn to create objects using this very nice line here on line 23. You learned how to organize your information that you require to create objects. Otherwise, we would have created these objects one by one, and it would have been a very painful process. You also learned to use constants when necessary. You also learned how to define and use random numbers. I think this marks the end of our video. I hope you enjoyed the video. And since this video is released on Christmas, Merry Christmas.